If you want to pass the GED science exam, you need to know what to study. When you have an understanding of what will be on the test, you can study more effectively. In this video, we'll be talking about what you'll need to know about chemistry to score 145 on the GED science test. This is the 6th video in a series about the GED science test. So far, we've talked about life sciences as well as an introduction to chemistry, so you may want to go back into the GED science playlist if you missed those. Today we're going to keep going with chemistry with the discussion about the properties and states of matter. Having a better idea of what you need to know about can help you focus your attention on the best resources for you. Like always, this is not an exhaustive overview of this topic, but I hope it will be a great place for you to start as you begin studying. Alright, so last week we started our discussion of atoms and molecules with the science definition of the word matter, anything that takes up space. In science, mass is the term that we use to describe how much matter any object contains. Mass is different than weight, which is a measure of the gravitational force that is exerted on an object. This is the reason you might have heard that you would weigh less on the moon, because less gravitational force would be exerted on you by the moon, which is smaller than the Earth. However, your mass would be the same either on Earth or on the moon. Matter can take 3 states: solid, liquid, and gas. Matter is solid when it has a definite shape and volume. This means that no matter what container you put a solid in, it will not change the shape or the amount of space that it takes up. This is because the molecules in solids have fixed positions and do not move around as much. The molecules of some solids form an orderly pattern called a crystal. A solid you're certainly familiar with is ice, which is the solid version of the chemical compound H2O or water. Matter is liquid when it has a definite volume but not a definite shape. This means that a certain amount of liquid would always take up the same amount of space, but that it'll adjust its shape to conform to the bottom of whatever container holds it. This is because the molecules in a liquid are loosely bound. Therefore, they move about more freely. The liquid form of the chemical compound H2O is water. Matter is a gas when it has no definite shape or volume. Gases will conform to both the size and shape of any container. This is because there's a weak attraction between the molecules of a gas. This causes them to move around constantly, bouncing off the sides of whatever container they're in. This means that an amount of gas with the same mass would expand to fill up a larger or smaller container. There would be no part of the container that didn't have gas in it. The state of matter can be changed by adding heat energy to a substance. You have experience with this. When you take an ice cube out of the freezer, it starts to melt. When you heat a solid, the motion of the molecules it contains increases. This loosens the bonds between the molecules and allows the matter to flow more freely. You also probably have experience changing a liquid to a gas. When you heat water, the motion of the molecules increases even more. You can see this increased movement of the molecules as the water starts to boil. The boiling point of water is 212 degrees Fahrenheit or 100 degrees Celsius. When water reaches its boiling point temperature, it evaporates into a gas. Many people think that the plume of steam above boiling water is water as a gas. But that's actually just small droplets of liquid water in the air. When water does evaporate, it is no longer visible. This process of changing states also works in reverse. When you remove heat from a gas, the molecules will slow down again and the gas will become a liquid. This is called condensation. You've probably seen this before if you've had a cold drink on a hot day. Gaseous water in the air condenses into a liquid when it encounters the cooler temperature of the container of your drink. If you remove heat from a liquid, for example by putting water into a freezer, the liquid will solidify. The temperature at which a liquid becomes a solid is called the freezing point. For water, that temperature is 32 degrees Fahrenheit or 0 degrees Celsius. By the way, For Americans who are not used to the Celsius degree scale, you might have noticed that the Celsius freezing point for water is 0 degrees and the Celsius boiling point for water is 100 degrees. These might be easier to remember than the Fahrenheit temperatures of 32 and 212 degrees. This isn't an accident. You can think of the Celsius scale as being uniquely suited to describe water, with 0 degrees or less as solid, 100 degrees or more as gas, and everything in between as liquid. The freezing and boiling points of every substance are different, and water is actually unique in that it's the only substance that appears naturally in all 3 states on Earth. The Fahrenheit scale seems weird when you're thinking about freezing and boiling water, only because the Fahrenheit scale is not focused on those things. Instead, Fahrenheit is focused on the human experience of temperatures. I was actually recently reminded of this by Hank Green's TikTok. You can think of Fahrenheit temperatures as a scale where 0 feels really cold as like an outside ambient temperature, and 100 feels really hot. So a day where it's 95 degrees Fahrenheit outside feels like 95% hot. And this definitely feels true to me. I've always felt this way when I've traveled in Europe. 35 degrees Celsius does not feel descriptive of the hotness that I'm going to experience, but 35 degrees Celsius is equivalent to 95 degrees Fahrenheit. Anyway, this is the formula for converting between the 2 scales. You can use it to find equivalent temperatures between the 2 scales, and you should feel comfortable using equations like this on the GED test. Last notes about states of matter before we wrap this one up. In the last video, I mentioned that when 2 or more substances combine physically, we call that a mixture. In chemistry, we talk about a special kind of mixture called a solution. A solution is a uniform mixture, so no chunks or parts that are not mixed up appropriately, made up of ions, atoms, or molecules of 2 or more substances. A solution that you are probably familiar with is called a saline solution, which is a mixture of sodium chloride or salt and water. There are 2 parts to any solution, the solute and the solvent. The solute is the substance that gets dissolved. In our example, the solute is salt. The solvent is the substance in which the solute gets dissolved. So in our example, the solvent is water. Water is actually considered a universal solvent because there are a lot of substances that will dissolve in water. Even though we might be more familiar with liquid solutions, solutions can also be solids or gases. Metal alloys are an example of solid solutions. Steel is an example of an alloy that you might be familiar with. Steel is a uniformly mixed solution of iron and another substance like nickel or titanium or carbon. The air that you breathe is an example of a gaseous solution. It's a mixture of nitrogen, oxygen, and other gases. Okay, so that was a brief introduction of states of matter that you need to be familiar with to do well on the GED science test. Of course, there's a lot more to be known about this, so please let me know what questions you have in the comments. I definitely recommend that you take some time with the GED prep manual to read more in depth about these topics and to try some practice questions where you'll read passages and look at diagrams like you might see on the test. I recommend the Kaplan GED prep manual, which I will link for you below. You can also use any GED prep manual that your local library has available to borrow. I also recommend that you check out the online resources that are available. Crash Course and Khan Academy have great in-depth chemistry series, but again, don't worry about memorizing anything because you don't need to be an expert. On this channel, I make videos about how to study more effectively so that you can achieve your goals. In the coming weeks, I'll be discussing what else will appear on the GED science test, so please subscribe if you'd like to learn more. I have GED series about all 4 tests as well as some videos about how to get started studying if you haven't started yet. If this video was helpful to you, please press the like button so that YouTube knows this is a good resource. Your support is what makes it possible for me to make these videos. Thank you as always for watching, and until next time, happy studying.